So if you're watching this video, it's because you wanted to see an example problem of an elastic collision. So the basic problem goes, there's two air tracks carts. They both have a mass of 1.5 kilograms, 1.5 kilograms, and initially, I'll draw a line between my before and after, they're heading towards each other with an initial velocity of 1.25 and 1.8. I know that the collision is elastic, and I want to know what are their velocities afterwards. Okay, so because this is an elastic collision, I'm going to use both conservation of momentum, so the sum of all the momentum at the beginning equals the sum of momentum at the end, and conservation of kinetic energy. So all the kinetic energy at the beginning equals all of the kinetic energy at the end. Okay, so that being said, we're going to go ahead and plug in. We have m1 v01 plus m2 v02 equals m1 v1 plus m2 v2. Okay, so we're going to have two variables. We know the masses, obviously, and the initial velocities, but we don't know either of the final velocities. I'm going to go ahead and fill in the masses first, and the reason I'm going to do that, and if you read this question and realized they're the same mass, you maybe would have thought to do this without plugging them in, but basically it looks like every single term has a 1.5 in front of it. So if I divide both sides by 1.5, because both of the masses are the same, divided by 1.5, I end up with v01 plus v02 equals v1 plus v2. So now I can just plug in the numbers that I have for v01 and v02. So I have 1.25 plus 1.8 equals v1 plus v2. Okay, so this is going to get 3.25 equals v1 plus v2. And just because I know I'm going to have to plug one thing into our other equation, I'm going to solve for v1. You could solve for v2. It doesn't make a difference which one you solve for, and you end up with v1 equals 3.25 minus v2. I'm going to box this equation because it's probably going to be useful later, and I'll number it. It's number 1. Now I'm going to go ahead and look at conservation of kinetic energy. Okay, again, this is only true when you have an elastic collision. So I have 1/2 m v01 squared plus 1/2 m v02 squared equals 1/2 m v1 squared plus 1/2 m v2 squared. Once again, all the masses are the same, so I can divide them out of the equation. I also don't care about all these 1/2s. So if I divide both sides by 1/2 m, 1/2 m, I end up with v01 squared plus v02 squared equals v1 squared plus v2 squared.